Hello, my dear friends. I am Soham Jagat. Welcome you all in science class. In last lecture, we have discussed about some basic and introductory part of work. In chapter number 11, work and energy, we are discussed what is work. In that, we have discussed that what we understand by work in our general term is different from science point of view. In that we have seen when we apply force on any object, if it will move, then and only then we can say work is done. Which means if we apply force on object, it should move by application of force. If it will not move, we can say that work is not done. Related to that, we seen some examples when work is done and when work is not done. In that, we have discussed two conditions that should be satisfied, or we can say must satisfied, when we say we want work done. So here we notice one point. A closer look at the above situations reveal that there are two conditions need to be satisfied for work done. The first one is force should act on an object, which means there is a present of force should be there, and another object must displaced, which means object have to change its position by application of force. So we have two conditions that must satisfied for doing work. After that, if any one of the above condition does not satisfy or does not exist, we can say work is not done. This is the way we view work in science. This is slightly different from our day-to-day phenomena and understanding of work. In physics, or we can say science, work is a different thing. A bullock is pulling a cart. The cart moves. There is a force on the cart and the cart has moved. Do you think that work is done in this situation? Yes, there is a work done because force is applied by bullock on cart, and by the application of this force we have displacement of cart. So our two conditions are satisfied here, that is force should be act on object. So here we have force, that is muscular force of bullock, and object must be displaced. So here cart is displaced by the force applied by bullock. Here we have activity 11.2 for conceptualize discussion of work and work done. Activity 11.2. Think of some situation from your daily life involving work. In daily life, we are doing so many activities. For example, we are playing, we are working, we are eating, we are cooking. So all this activity according to us are related to work. Discuss with your friend whether work is being done in each situation. If we are playing, work is done because we apply muscular force and we have displacement of our body or anything object which with we are playing. If we are eating, we apply muscular force on food. We take food, which means we apply force on food. By application of this force, displacement takes place, so it involves work. If work is done, which is the force acting on the object, as we discussed, for example, we are playing with bat and ball. If someone throws ball and we hit the ball, in that situation we apply force by our hand that is transmitted to bat, and this bat apply force on ball. By this force or application of force, ball displaces from its original position or it change in velocity. So we can say that by application of force, work is done because we have force apply on object and also displacement of object. What is the object on which the work is done? In above example, we discussed bat and ball. Work is done on ball by bat. What happened to object on which work is done? By applying force on ball by bat, ball changes its velocity, which means there is a change in magnitude and also in direction. So here we can see some example, and we discussed example of in which case work is done and in which case work is not done. Let's say sometimes after thinking too much of things, we said we did work, but in scientific term there is a no work involved in thinking, because in thinking we don't apply any force, or by application of any force we don't have any displacement. So thinking is not an activity or say work done as science point of view. So I hope you understood what is work according to science. There must involve force and displacement. Now we have activity 11.3. Think of a situation when the object is not displaced in spite of force acting on it. We have to think about situation when we apply force but object does not move. For example, if I apply force on wall, huge wall, will wall move or displaced? No, it will not, because my force is not sufficient to move this wall. So in this case, I apply force. So we have force, but second situation, displacement, there is a no displacement of wall. So we have no work done in such cases. Also think of situation when an object gets displaced in absence of force acting on it. We have to think about the situation when object get displaced in absence of force acting on it. If we have some object that is on frictionless ideal surface, so ball gets displaced without any external force applied on it. List all the situation that you can think of for each. As we discussed, some situation that is related to work done without applying any force, or we can say any hypothetical situation that displaced without force, and a real situation when work is not done as we apply force but displacement are not taken place. So here we have another topic, work done by constant force. Topic number 11.1.3, work done by constant force. How is work defined in science? To understand this, we shall first consider the case when force is acting in the direction of displacement. Now we have to define work. What is work in terms of science? So we have one experiment. Let a constant force F acting on an object. Let the object displace through distance small s in the direction of force. What is meaning of in the direction of force? Which means if here I have object and I apply force in this direction, it will move in this direction. If I apply force in this direction, this object will move in this direction, which means displacement in direction of force. So our force applied is capital F, and by application of this force we have displacement small s. Let W be the work done. We define work to be equal to product of force and displacement. We have to note this. We define work to be equal to product of force and displacement. So by definition, we can derive its formula. Work done is equal to force into displacement. So we have W is equal to F into S, where F is force applied on object and S is displacement of object. Here we have table. On that table we have block. On this block we apply horizontal force of F Newton, and by application of this force we have displacement of block by S meter. Thus, work done by the force acting on an object is equal to magnitude of force multiplied by distance moved in direction of force. Work has only magnitude, no direction. Work has only magnitude, no direction. Now I think you can conclude that work is scalar quantity because it has no direction. In equation number 11.1, if we take F is equal to 1 Newton and displacement is 1 meter, then work done by force will be 1 Newton meter, which means if in this equation 11.1 we take F is equal to 1 Newton here and S is equal to 1 meter, then we have W work done is equal to 1 into 1, that is 1 Newton meter. So SI unit of work is 1 Newton meter, or say Newton meter, and this Newton meter we called it as joule. So the SI unit of work is joule, and 1 joule is equal to 1 Newton meter. 1 joule is equal to 1 Newton meter. Thus, 1 joule is amount of work done on object when a force of 1 Newton displaced it by 1 meter along line of action of force. What is line of action of force? Line of action of force, that is similar to direction of force. If I apply force in this direction, that is towards left, so this is the line of force. This is the line of action of force. Here we have one example. Let's say here this girl try to pull this car. So this string she is pulling this car towards her. So this string direction is line of action of force. Here in above example, this direction is line of action of force. Look at equation number 11.1 carefully. What is the work done when force on the object is 0? And what would be the work done when displacement of object is 0? Here in equation number 11.1, we can see that if any of term, that is force or displacement, would 0, we have work done is equal to 0. So for any positive work, we need force and displacement. If F will be 0, we have 0 work done. And by application of F, if S, that is displacement, will be 0, work done will be 0. So from equation, we can say that for work done, we need force and displacement both. Now we have another paragraph. Consider another situation in which the force and displacement are in same direction. For example, a baby pulling a toy car parallel to ground as shown in figure 11.4. Here, as we seen earlier, here a baby girl try to pull this car in right hand side direction. For that, the baby has exerted force in direction of displacement of car. If I pull car in this direction, I have to apply force in this direction. In same direction, car will displace. In this situation, the work done will be equal to product of force and displacement. In any case, work done is equal to force applied and distance covered due to force. In such situation, work done by force is taken as positive. In which situation work done is taken positive? When object displaced in direction of force applied. When object displaced in direction of force applied. In such situation, work done by force is taken as positive. Let's see opposite type of situation. Consider a situation in which object is being displaced by action of force and we identify one of the force F acting opposite to direction of displacement S. Let's say here I have one object that is moving in this direction by some force, external force that is applied on it. Now we have another force in opposite direction, but this object is still moving in this direction. This force is applied in this direction, but this object is still moving in this direction. So by application of force also, displacement is taken place in another direction. So here direction of force is in this direction and direction of displacement in this direction, which means there is opposite direction of application of force and displacement. So in that case, F acting opposite to direction of displacement S, that is the angle between the two direction is 180. Here we have force and here we have displacement. So angle, that is this angle, this total angle is 180 degree. I hope you can understand. Here I have line and in between I have one point. So here I have angle 180 degree. If force apply in this direction and another force in this direction, this is perpendicular forces. If both force are in this direction, which means in this direction, right hand side direction. So here angle between two forces 0 degree, here 90 degree, and in this situation it is 180 degree. So I hope you understood what is the angle between two direction is between force and displacement is 180 degree. In such situation, the work done by force F is take negative and denote by minus sign. We can take work done minus because there is a opposite direction of force as well as displacement. If we take force plus, we have to take displacement minus. If we take sign of displacement plus, we have to take force as minus. But multiplication of positive and negative will always become negative. So here in this case we have negative work done. And when we get negative work done, when application of force and displacement are in opposite direction, or we can say angle between these two is 180 degree. It is clear from above discussion that the work done by force can be either positive or negative, which means work done can be positive or negative. To understand this, let us do following activity. We have activity number 11.4. Lift an object up. Work is done by the force exerted by you on object. Let's say I have this object and I lift this object up. I lift this object up. So I applied force on the object, and by application of force I displace this object. Here in initial situation it is in this situation, but when I apply force it displaced. So the object moves upward. The force you exerted is in direction of displacement. I applied force in upward direction and displacement of this object is also in upward direction. So as we discussed earlier, direction of force and direction of displacement both are in same direction. So here I can say that work done by me on this object is positive. Work done by me on this object is positive because direction of application of force and direction of displacement are same. Another situation, however, there is a force of gravity acting on object. Here if I release this bottle, it will move downward. Why it will move downward? Because here we have gravitational force on this object also. So it means that here two forces are applied at this time on this object. Here is a pulling force in upward direction by my hand and gravitational force that is in downward direction. But as I apply force, it is displaced in upward direction. but the gravitational force is in downward direction. As we discussed in previous chapter, that weight of object always acting in downward direction, that is due to gravitational acceleration. So here object is moving in upward direction and gravitational force in downward direction. So here angle between this two direction, that is displacement and gravitational force, is 180, or we can say in opposite direction. So here work done by gravitational force on this object is negative because force is applied in downward direction while this object moves in upward direction. So we have negative work done by gravitational force on this particular object. Which one of this force is doing positive work? So as we discussed, force applied by me on object is positive. Which one is doing negative work? So the gravitational force doing negative work. Give reason. We discuss reason because there is a change in direction or similarity in direction of work, or say force and displaced direction. Here we have conclusion. Work done is negative when force acts opposite to direction of displacement, and work done is positive when force is in the direction of displacement. We have to note this and remember this conclusion. When work done is negative, when force acts opposite to direction of displacement, and when work done is positive, when the force is in direction of displacement. So in this case, we derive in which case we have positive work and in which case we have negative work. Now we have another important topic of this lesson, that is energy. We use this word energy lots of time in our day-to-day life, which means we say sometime I feel energetic, I feel less energetic, I have no energy now. Let's see what is the relevance of this day-to-day life used word energy and scientific word energy, or say scientific definition of energy. Life is impossible without energy. We know that life is impossible without energy. I am delivering this lecture, you are watching this lecture, taking notes, you play, eat, walk, run, or even respiration needs energy. So without energy, we can't do anything. So life is impossible without energy. The demand for energy is ever increasing, and this demand for energy is ever increasing. We are with our electronic gadgets that is needed energy because we need electrical energy in that. We are driving our vehicles that needs chemical energy, that is we get from diesel, petrol, or any kind of gases. So we need energy and we need more and more energy in coming days because our lifestyle is growing continuously. And to maintain this growth and satisfy our needs, we need energy. Where do we get energy from? Here is important question. The sun is the biggest natural source of energy to us because due to sun we have vegetation, we have plants, and we all are. and all animals are dependent on this. So we have sun as the biggest natural source of energy. Many of our energy sources are derived from sun, as we discussed. We can also get energy from nuclei of atoms. You may heard word nuclear energy. So this is the energy from nucleus of atom we called as nucleus energy or nuclear energy. The interior of earth, we have lots of heat in interior of earth, and tides. We have energy in tides also. In next standard 10, we will learn this source of energy in one of our chapter. Can you think of other source of energy? Can you think any another source of energy that we are using in our day-to-day life?